So we are back. I'm going to continue solving another problem. The second question is this one. Y second prime plus 9y, which is equal to 2t e to the negative 3, right? So first, as I did in my first example, I need to find out the auxiliary equation root. The auxiliary equation in this case equal r squared plus 4, right? R squared plus 4, which is equal to 0. So my roots are going to be negative plus 2i. Then my homogeneous part of the solution, since I have just a complex root and an imaginary part, I will have C1 cosine 2t plus C2 sine 2t. If you have a problem, finding out, the homogeneous equation, please go back and then see the related part in your notes. I need to choose a particular solution based on what I have on the right hand side. What I have on the right hand side, a polynomial, first degree polynomial. That's why I'm going to have a first degree polynomial on the right hand side. I also need to put my exponential function, but I'm going to be asking if I need this extra term. To determine my extra term, I need to compare my r value here, which is equal to negative 3, and then see if it is equal, one of the roots. As you see in this case, negative 3 is not equal one of these roots. That's why, I'm not gonna need any extra term. So it is not a root of auxiliary equation. That is why we can assume that S is 0. Now I'm gonna continue without the extra term. That's better, right? So it's gonna make my job easier. So yp is gonna be equal at plus b e to the negative 3t. And I will need the first derivative, which is gonna be equal a times e to the negative 3t plus negative 3 times at plus b e to the negative 3t. My second derivative is going to be equal to negative 3a e to the negative 3t, and another negative 3a e to the negative 3t, and also I need to multiply by negative 3 since I'm taking the derivative of this part. So it's going to be 9a, positive 9a, negative 9, just negative 9, times, the rest of these terms. So at plus b e to the negative 3t. I can group the terms since I have mean the two terms in this case. One of these terms are the terms the t times e to the negative 3t. You see, I have them here. And then I also have another type of term. Those are just the constant terms. They have the e to the negative 3t terms. So now I'm ready to add them, to continue. But first, I need to multiply these by the coefficients I have. So I have just one coefficient here in front of this one. That means I don't need this term. Look at that. No need. Yp prime, since I don't have that term in my differential equation. If I add these two terms, yp second prime plus 9 yp, I'm not gonna add, okay, in one line. What I will just do, right, I will add them right in, okay, let's add them. Let's add them. So if I add them, 9a minus 3a, sorry, I don't need to add this term. Sorry, my bad. Okay. I will just add the yp prime. If you look at here, I had the 9a term there, right? 9a term. So e to the t times e to the negative 3t. Which is equal 2t e to the negative 3t, correct? And I also have some other terms around, which they are equal 7, 6a, and plus 9b, in, right, from the first term, 9b, and then also I have 9b from the first term. Okay, let's see, 9b, yes, and then I have negative 6a from the yp second prime, and then I also have the 9b from the, right, again, yp second prime. Should be equal, right, 0, since I don't have any constant in my function on the right-hand side. So from the first side of the equation, 18a is going to be equal to, which it will show me a is equal 1 over 9. And from the second one, 18b is going to be equal 6a, b is going to be equal a over 3, which is equal 1 over 27. Great. Now, I can write my yp is equal t over 9 plus 1 over 27, right, times e to the negative 3t. And at the end of the question, I need to state yg is equal yp prime yh, okay? I don't need to write one more time since you already found them out, but if you want, of course, you can go ahead and then you can add them, okay, at the end of the questions. We have another quadrant here. So in this case, I have the 40e to the t, but we're going to see that, okay, one of the roots is going to be equal to write the coefficients on the exponential function. Let's solve the auxiliary equation first. Auxiliary equation is going to be equal r squared minus 3r plus 2, which is equal 0, and then r minus 2 times r minus 1. So I can find out my roots are going to be equal 1 and 2. And my homogeneous solution to this one, since I have two distinct roots, that's why I'm going to have, right, two linearly independent solutions. I can combine them linearly, okay, to have my homogeneous solution, which is going to be equal c1e to the t plus c2e to the t. When it comes to, right, the particle solution, I need to choose in this way. I have first degree polynomial, and then I have another exponential function there, but I'm asking if I need, right, using the GC1, if I need the extra term. To do that, as you see, I have, right, the value r is equal to, right, is a root, a simple root. It's a root of auxiliary equation. This is why, of course, I'm going to need, right, an extra term. S is going to be 1. So in this case, my particular solution is going to be equal yp, right, t times at plus b, but I need to multiply. If I multiply them, I'm going to have, right, this one, at squared plus bt times e to the tt. I need to continue by this term. I'm going to take its derivative. So derivative of this one, 2at plus b times e to the 2t, and plus 2 times e to the 2t times at squared plus bt. My p second prime is going to be equal 2a e to the 2t plus 2 times 2at plus b e to the 2t. Another same term needs to come from here. Look at it, since I took the same derivative before, you can notice that, which is equal to 2at plus b, and then the last term I'm gonna have 4e times 2t times at squared plus bt, guys. I'm gonna need to use my coefficient. I need to multiply this by 2, right? Sorry, times 2, and negative 3 times 2 is going to be negative 6. Then I'm going to add all these terms. Let's see if I can manage to add all these, right, in this restricted area, since it's not going to be easy, okay, to remember all the terms. That's why we need to be careful. Okay, so I'm going to do the similar approach, right? I need to group them. I have at squared term here, here, and the last one is here. So if I add them, I would have 2a minus 6a and plus 4a. So this is t squared e to the 2t terms. I can just make this equal to the right hand side, but I don't, if you look at back, right, I don't have any t squared e to the 2t terms on the right hand side. That's why I can write in this way. But if you look at the left hand side, it's already 0, so I'm even, right? You don't need to calculate anything from this equation. So the second one, the second terms I can use, look at that, t terms. So I have t term here, I have t term here, t term, a lot of t terms around, right? If I add them together, from the first line I have 2b, right? And from the second line I have 6a, and also 6b coming from the second term. I have 4a, another 4a, and plus 4b. A lot of the t terms around. So t times e to the 2t. And then I just have one term on the right hand side for t e to the 2t. Great. These are my yellow terms, right? These are my yellow terms. If I add them, okay, let's add them directly, okay, without using any color. So 6b, 4b, right? My great, 6b, 4b, sorry, 2b, 4b, which is equal 6b, and then 6b minus 6b, which is equal 0. 4a, right? Another 4a, and then minus 2a, which is equal 2a. 2a is equal 4. That's why I can find out a is equal 1 over 2. Great. But I have some other terms around, right? We remember. Do we have? Or did we? We have some terms. If you look at back, we have these constant terms there, guys. I gotta do 3b plus 2a plus 4b, which is equal 0. So I have an equation here I can solve for b, since I already solved for a. B is going to be equal negative 2a, and then from here, since I know what a was, b is going to be equal to negative 1. Great, right? So my yp here, right, from this one, at squared plus bt was my original equation. So t squared over 2 minus t times e to the 2t is going to be my particular solution. And then I'm going to write the complete problem by stating the general solution. General solution is equal yp plus yh. Yp was equal, right? Was equal c1 e to the 2t plus c2 e to the t, sorry, this is a yh, this is the homogeneous part, and then yp is equal, look at the t squared over 2 minus t e to the 2t. So you can prefer to write in this way as well. I just wanted to show you, okay, you can do that.